Welcome to part 2 of our video tutorial, Symantec Backup Exec Server 2010, Designing a Backup Scheme. Once the plan for organizing and retaining backups has been established, you can move on to determine how to configure your backup devices to support your media sets. If you are using a set of tapes as your backup media, the most important step is to establish a tape schedule. This will involve determining what tapes are to be used for each of the backup intervals. You will also need to determine who will be responsible for changing and storing the tapes and for cleaning the tape drive. If you are using a robotic tape library with many tapes, you will want to determine which tapes go in which slots and partition these slots within Backup Exec. This allows you to assign backup jobs to specific slots and gives you assurance that your backup will be stored on the correct tape. If you are using tapes for your backup media, these steps are critical for keeping the tapes manageable and organized. If your backup hardware involves storing the data on one or more disk volumes, you will need to create backup to disk folders within Backup Exec. Backup to disk folders are simply folders where the backup data files are created and stored. These folders can be on local disks or on shared volumes across a network. When using backup to disk folders, it is important to consider the designation of a low disk space threshold. This is the amount of free space that will cause the backups to halt. It is also important to verify that the Backup Exec service account has access to the backup to disk folders, because the backup jobs will immediately fail if it does not have access. Lastly, you will want to put some thought into the arrangement of the backup to disk folders, since they should be easy to identify and manage. If there are several layers of backup hardware within your design, Backup Exec enables you to configure device pools. Device pools allow you to associate and prioritize sets of backup devices so that when the jobs are executed, they will run on the most appropriate device available. One example of a device pool implementation would involve using a tape drive as a primary device, but failing over to a backup to disk folder in the event that no tape is available. Now that we have completed all the preliminary steps, we can begin to decide when and how the backup jobs will be executed. Since we have already established how frequently backups need to occur, all that is left to do is select backup times that will cause the least amount of impact on the infrastructure and its users. You will need to have an intimate understanding of when the systems are in use and when maintenance tasks are running. Be sure to plan your backup jobs with respect to both of these schedules. Next, we will have to decide what types of jobs will be performed and in what sequence. If your infrastructure has a significant amount of data, but only a small portion of it is changing during the backup interval, a full backup every time would not make much sense. In Backup Exec, there are three basic types of backup jobs: full, differential, and incremental. Full backups are complete backups of all the resources included in a particular job. These types of backups produce the largest amounts of data, are the most resource intensive, and take the longest amount of time to complete. Differential backups will back up only the data that has changed since the last full backup. These types of backups produce smaller data sets, use fewer resources, and take less time. Differential backups are most effective when used to fill in gaps between full backups. Incremental backups will only back up data that has changed since the last full backup or the last incremental backup. These types of backups produce the smallest data sets, use the fewest resources, and take the shortest time. Incremental backups are useful when scheduled between full backups and during intervals that occur often to record data that is frequently changing. Choosing the most appropriate type of job to run at each given interval depends on how much data is changing and the frequency of the intervals. Always plan your backup jobs to protect the data as it changes and to make the most effective and efficient use of system resources. For example, let's say you were backing up sets of files daily and there was a moderate amount of data changing from day to day. It would make sense to perform differential backups over the course of the week and then perform a full backup over the weekend. A different scenario would be if you were backing up a database every hour and there were small amounts of data changing very frequently. It would make sense to perform incremental backups throughout the day with a full backup at the end of each day. Lastly, be sure your jobs are running with the appropriate permissions and that the backup system is secured against unauthorized access. By design, a backup system has access to all the critical resources and data. That is why it is essential that the backup system be given no more permission than what is required to operate, and that access to the system and its media be tightly controlled. In conclusion, it is imperative that you take the time to plan a thorough backup scheme to ensure your business's data is properly protected. The scheme must be well thought out and well implemented because a faulty backup system is useless in the event of a serious disaster. All backup solutions should have several layers to protect against data loss. You should have redundancy at the hardware level by using multiple storage media and systems such as a RAID array or storage area network snapshots. You should also have redundancy in software by using solutions like Backup Exec in conjunction with Windows Volume Shadow Copy and native database backups. Having layers of redundancy will ensure that there is no single point of failure for your system. For the same reason, off-site backup is critical in the event of a catastrophic disaster such as a fire, flood, or earthquake that could destroy the primary and backup systems all at once. While designing your backup scheme, you need to be imagining a worst-case scenario and using it as inspiration to lay out your disaster recovery plan. Even the best backup scheme needs a disaster recovery plan to turn to when the unthinkable happens. Finally, test your backups, and lastly, test your backups at all levels to ensure that they will actually come through in the event of a disaster. Testing needs to occur at the file level, the database level, the system level, and even at the site level to ensure that your backup system has the business sufficiently protected. All the points I have discussed today will hopefully enable you to have a better understanding of all the dynamics involved in designing a backup scheme for your business and will help to protect your business against disaster. Thank you for joining us, and if you found this tutorial video helpful, please subscribe to Nextara, our YouTube channel, and visit us at our website www.nextara.com. Thank you.